So I'll read the definition that the book provides, and then we'll actually talk about what they mean. So one way that you can tell that you have a zero force member in a truss is if you see a joint that has only two non-collinear members with no external forces acting upon that joint. So if you've noticed, they've circled joint D here. There's members DC and ED connected to joint D. And if I were to draw lines along the axis of member ED and member DC, you notice they're not aligned with one another. That's what it means to not be collinear. So going back to a lot of, so for an easiest example, if you look at joint B here, the member AB and BC, those two members are collinear, because if you were to draw a line that goes directly along the axis of both, it's the same line. So with respect to joint D, ED and DC are not collinear. So since at this joint, there's only two members that are attached and there's no external loading applied at this joint, you know that members ED and DC don't actually do anything with respect to the load-bearing capability of this truss. They're known as zero force members. And what they're showing you below is if you were to reanalyze, so you can analyze the truss as is at the top, you're just going to have a lot of boring mathematics, like when you enforce equilibrium on this pin. Just think about drawing a free body diagram. If you assume these members are in tension, meaning they're pulling on the pins, you got member ED pulling the pin this way, down and to the left, member DC pulling it straight down. Well, if member DE is pulling it down to the left, there's nothing to counterbalance the force to the left. So clearly member DE must be in zero force units of tension. Well, if there is no, if member DE is in zero force units of tension, not only is it not pulling to the left, but it's also not pulling down or up. So if it's not pulling down or up, there's nothing to counterbalance the downward pull by DC. So the force induced in member DC must also be zero. So easy way to spot it is just look for joints where only two things are connected, and those two things don't lie along a straight line. So here, right, two things are connected, A, B, there's no external load applied, and those two don't lie on a straight line. You will know that those are zero force members. So you can take them out in the analysis and get the same answer. So if you have three members connected at a joint and two are collinear, what you know naturally is, and again, assume that there are no external forces acting upon that joint either. So three members going into a joint, two of the three are collinear, no external forces. You naturally know that the member that's not collinear is also a zero force member. And you can kind of convince yourself by just thinking about how the free body diagram for each of these joints would look as well. Naturally, the component that's directed along that collinear axis at point D, we know those need to be equal and opposite. But what's left to cancel out any pull from member AD on that pin? There is nothing, because these two are purely collinear to one another. So naturally, this must be a zero force member. So in terms of another way to spot zero force members, first slide, look for joints that have two members attached that aren't collinear with no external forces. And if you have three members attached, if two of the three are collinear and there's no external forces, then the non-collinear member is zero force. In the prior example, both of those members would be zero force. So hopefully that makes sense. You can kind of, if you're confused at all, just take out a piece of paper and draw a free body diagram, and you will prove it to yourself really quickly. So this will conclude Chapter 6, Part 1 of the lecture, which will be everything that you need to get through Exam 2. And as I mentioned, you don't even need this last learning module.